Thank you so much for your continued attention as we get set up for our first panel, and thank you very much to UCV for hosting us, such a well-organized conference. Just as our speakers get set up with their microphones, just to introduce us, this panel, Data-Driven Decision-Making, Smart Cities, Environmental Data, and Monitoring and AI, is very critical to the goals of EU-CONEXUS. It brings together the finest and the newest thinking on smart urban coastal sustainability. And our speakers cover innovations from the macro right down to the micro scale. So our speakers will first individually respond to the theme and present their current innovative research. And when all have presented their research, we'll then have a chance to open the floor to questions. So we'd welcome questions at the end of all the talks from all of you. So please do pay attention. We begin, first of all, with Henrik Jansson. Henrik is an urban designer from Germany, and he's Professor of Sustainable Urban Design and Mobility at the University of Rostock. His research focuses on inner urban development and mobility transition in cities. He has held academic positions at TU Dortmund, ETH Zurich, and MIT. In parallel to his academic work, he co-leads the urban design practice Blaser Janssen Partners, based in Dortmund and Berlin. So I welcome Hendrik, and first of all, I ask Hendrik, how is data and urban planning? What are the possibilities for them to benefit from each other? So I welcome Hendrik. If you'd like to present from here, Hendrik, that'd be great.
So much.
Thank you.
Yeah, hello, welcome. Happy to be here. Happy to be the first time at this CONEXUS network. I'm at the University of Rostock since 1 year now, so it's the first time to be connected to all of you, and it's my pleasure to be here. Well, before we started this panel, we were sitting together and thinking about what is the best idea to kind of structure the presentations, and we said that we're starting from a big scale and then going to a smaller scale. So I decided that I'm starting with a very big scale, and I have listed up the most critical challenges of Earth system boundaries, at least according to Ockström, an article he recently published in Nature, and he identified these 9 challenges of Earth system boundaries, and the one that is most relevant for me as an urban planner, that's the land use. So I want to talk a little bit about what is my idea about land use and how we are building our cities and how data and digital tools can help do this. So first of all, when we think about cities, at least for us as urban planners, we think about cities that are very compact, that have a compact urban form. I brought you a picture that kind of illustrates what that means. Many of you might know this idea of the 15-minute cities. So a city that is compact, that has a lot of mixture in its uses, that has short ways how to reach different places in the city, and that is basically the idea that we're all following as urban designers, and I think a lot of these aspects you can also find here in Valencia, as far as I experienced it so far. So this is actually what we're heading for, and this is also the question: how are we going to use the land that is already existing? So I think, in my opinion, the city that we have to build is already existing. We have to make ideas on how to make it more dense and also more livable. So this is 3 aspects that I use very frequently when I think about how to develop cities from within. In Germany, we have an idea or a concept that is called triple inner urban development, and it basically deals with this idea that we think about the urban fabric, so how to infill, how to replace, also how to do and add stories, for example. But it's also dealing a little bit with the idea of mobility, how to do bike parking, how to do also structured parking in garages, think about bike lanes, so anything that's connected with sustainable mobility. And it's also dealing with the idea of open space, so how to put more public green space, roadside green roofs, green facades, so to think it all in an integrated way. And this is basically the idea of triple inner urban development. And as you might see, this is also kind of it's going a lot into existing structures, and by that also concerning a lot of people that are living in these environments. So what we're actually doing in collaboration with a startup from Berlin is that we're commissioned to do a few of these so-called inner urban development concepts. And in that sense, we're trying to make concepts on how to add up existing structures, how to add up new buildings, how to add up also new green spaces. And we are doing this in a web-based tool that our partners from PoliceU have developed, and we're using it with our clients from the city of Berlin. So we're kind of trying to use a data platform that is providing us kind of real-time planning scenarios that you can see here in order to connect them with data. And the data that is being produced, you can see it on this side here on the left, so you can easily see how many units are being produced, how much additional space, but you can also kind of calculate how much additional free space, open space, and also parking space is needed. And in that sense, you can try to make some more realistic and some more realistic scenarios of different planning scenarios. And discuss them. Also discuss them within the disciplines, with the different sectoral planners, but also within the general public. So how does this work? We're actually trying to get a lot of data that is already existing with this platform and these concepts. As you can see on the left side, Berlin has a geo-portal that is already providing a lot of data. So we actually just have to make it accessible in that sense. We also have an open data platform Berlin, which is providing a lot of 3D building data as well. So what we're doing is actually we're taking this data that is existing, we're kind of transforming it into the platform. We have buildings, vegetation, we can also say things about density. And then in the second step, we're also using it to do planning concepts. For example, infill concepts. We can also measure easily distancing spaces. We can see which buildings are being replaced. And a lot of different other things like shading, for example. So we're having this platform and we're kind of filling it with a lot of existing data, but we're also making planning scenarios with it where we can show also the general public how the city might look when this concept is being implemented. And this is a picture that shows a little bit how we use this platform, but also kind of more traditional planning concepts when it comes to public participation. Because we're using this platform also to discuss ideas with the general public, which is very important in my opinion to also show people how we're gonna do urban planning and how their neighborhoods are being changed. In my opinion, this helps a little bit to give them a bit more an idea on how we work as planners and how we use the data, and in that sense also makes them more aware that some changes might be necessary. So I have three takeaways. Like three key takeaways, maybe we can also discuss them together. So the first idea, from my opinion, is that inner urban development stays a major strategy to control land consumption. We have to keep cities very compact, we have to keep them also dense, but at the same time think it integrated in terms of mobility and also open space. The second point is that, in my opinion, a lot of data already exists, at least for Germany that's the case. It has to be made accessible. And so far we don't have so many tools yet to make it accessible, even though a lot of data is already there. And then also it's of course about the idea of the sovereignty of data. You know, not all data that we have is accessible by the public. And the last point is actually the data and its visualization can increase the trust in planning decisions, especially by the general public. If we make people aware on how we do our decisions and show them what kind of data we use for it, it's much more likely that they accept it and that they also support certain things. And as you all might know, urban planning projects are always projects that are concerning everyone and everyone is affected by them. So it's very important that we have the trust of the general public to implement them in the process. That's so far. Thank you so much.
Thank you. And at the end of all presentations, we'll welcome questions. So thanks, Hendrik. I'm sure people will come back to you with more questions. In the meanwhile, we're going to hear from Gemma Roig-Pollard. Parado, apologies if my pronunciation is not perfect, Gemma. Gemma is a telecommunications engineer with over 15 years experience in mobile communications and innovation. She currently works at Valencia Innovation Capital, the innovation agency of the city of Valencia, where she leads initiatives aimed at transforming municipal services through technology and innovation. So Gemma, today what we were asking you is how is Valencia in particular dealing with data and any links with innovation?
Thank you very much. Firstly, I would like to express my gratitude to the organization for giving me the opportunity to be here and tell you and have the opportunity to share with you all the projects that we are developing at Valencia Innovation Capital. Valencia Innovation Capital is the agency of the City Council of Valencia for innovation. What we do is to develop the city through innovation. Is the strategy of the City Council in order to promote a dynamic, diverse, and a creative city. Our claim is that technology is the how and the human being is the why. But at the end of the day, what we do is to collaborate very tightly with the different departments of the City Council of Valencia in order to work with them to discover the challenges, their problems. And we try to overcome these challenges using innovation and technology. Valencia is a recognized partner since its excellence. In 2024, Valencia was a European Green Capital. Valencia is one of the 112 mission cities to be climate neutral by 2030. Valencia has been 2 times in the last 4 years finalist of the Capital Innovation Award. And in 2022, Valencia was selected as the best city for living, capital of smart tourism, world design capital, and healthy city. In the related with ICT, Valencia is worldwide recognized as a smart city. It was the first European city with a platform fully compliant with open standards with fiber. It was the first Spanish city with a smart city platform based on cloud services. It was a founding member of the Spanish networks of Smart City. It is platinum certification on the World Council on City Data with 99 KPIs, standard KPIs, and is active member of different kind of ITU working groups. Valencia, using its data and its smart city platform, has different assets and different developments that could support the decision of the city and could inform to the citizenship. For example, Valencia IPP, our transparency and open data portal, our geo portal, the portal Valencia by the Minute, which is a portal for the citizenship, or city dashboard, which is a dashboard for the politicians for taking decisions, and the COVID landing page. With all this information and all this data, Valencia has recently built its digital twin, an information digital twin with all the information that is in the Smart City platform available for visualization. This is a first stage, and the second stage will be make some simulation that could help the city for planning and for taking decisions. In the framework of artificial intelligence, Valencia knows, the City Council knows that it has to take the advantage of the opportunity that artificial intelligence is going to give to the city, and it's defining a roadmap based on 5 pillars. The first one is the public city, artificial intelligence in order to transform the public services, artificial intelligence for improving the city management, artificial intelligence as a pillar for innovation. The City Council also wants to prepare the city servants, the municipality, to the use of artificial intelligence, and also wants to work about the ethical and technological foundation in order to build one infrastructure very robust using artificial intelligence. Within this framework, we are partners of CITCOM project. In the framework of this project, what we do We are the third supernode built by the European Commission, and what we are doing here is developing different kind of tools that could support companies, universities, and entities that would like to develop artificial intelligence solutions. What we offer is different kinds of services that could improve and could help these entities to develop their solutions without spending less money. We are also members, in fact we are the chair city of the European Consortium of Digital Twin and Siteverse Digital Infrastructures of the European Commission. This is an initiative pushed by Digital Europe, and within this framework what we are doing is developing tools in order to support the city to develop their digital twins. We are also involved in different European projects. Right now, we are partners in 15 European projects. 4 of them has been recently achieved. It's bringing to the city about 6 million euros, and we are waiting for the resolution of 8 more projects. What we are doing in these projects, our role is to develop pilots in the city, to define the requirements of these pilots, solving the city challenges, as I was mentioning before. We demonstrate the solutions of these projects in the city, and we try to transfer these solutions to the usual business. Moreover, I would like to talk about our GovTech program. What we develop in this GovTech program is to overcome these city challenges, but in this case, what we want is to achieve that the startups, scale-ups, and technological SMEs could start to collaborate with the city council in a smart kind of grants. These kind of companies could offer to the city really good technological and based in data solutions that could help a lot to the city decisions and to the city working, but these small companies, it's really difficult for them to work with the city council because they have not the specific structure collaborate and to participate in big tenders. What we do here is to innovate in different ways with the contracting, fitting to the Spanish laws for sure, but innovating in this kind of tenders in order to make possible that these smaller companies collaborate with the city. Within this framework, we have developed different kind of pilots, all based in data and in artificial intelligence. One example of it, for example, is the second one. We are building a platform to measure and to gather all the innovation indicators of the city of Valencia and its metropolitan area, for example. Moreover, we have, I think it's the 6th one, we are developing a platform in order to help us to analyze the offers that we are receiving for the subsidies that we are publishing every year in the City Council, the innovation subsidies. These are some examples. And last but not least, I would like to talk here about our Valencia Urban Sandbox. What we say is that you bring the idea and we bring the city. Here we are offering the infrastructure of the city for testing innovative solutions that are not in a commercial stage yet. Here we have a list of more than 100 infrastructure of the city, parks, digital platforms, streets, lot of libraries, for example, the Palace of Congresses, for example, municipal buildings. We have a list of more than 100 city infrastructure, and we are offering this infrastructure for all the developers to test. If you have a solution that needs to be tested in a real and relevant environment of the city, Valencia could be your test bed. Thank you very much.
Thank you. Thank you, Gemma. And moving to some short-term potential solutions now, we welcome Professor Charles Ambos-Chassos, who is Associate Professor in Internal Combustion Engines at the Mechanical Engineering Department of Frederick University. Dr. Chassos specialises in CFD modelling for automotive and marine engines, alternative fuels, and participates in cost actions as well as in EU-CONEXUS Work Pact 7. So our question for Cheryl Ambos today is, looking at the short term, what changes can be made to reduce emissions to help us create sustainable cities.
Thank you, moderator, for inviting me. First of all, I would like to express my gratitude to the host institution of this research conference, the organizers, and all the people involved. And the question will be answered through my presentation, I think, or I give the answer straightforward now. I think it could be answered, and I'll try to do two things.
Yeah.
First, to relate with the previous speakers, and then to connect with the public, the audience, specialists, researchers, and public with not scientific knowledge. And as a driver, we need to think together. I mean, it's not my research, it's all of our concerns. So the idea of my presentation is to examine how the adaptability or adoption, because we adopt new fuels, but how to adapt, to make the adaptability in existing systems, which systems are involved in urban landscape. They emit combustion systems, they emit emissions. The environment is getting the burden from all these carbon dioxide and other emission pollutants, and especially urban and coastal areas. Coastal areas, especially with the accommodation of vessels, large ports, and this is Valencia, is one of the affected cities, 103 or 102 cities. Limassol in Cyprus is another of these cities. A solution that people think is the plugging of the vessels when they are at the port in order to avoid emissions. This is called ironing. But in my presentation, I will talk about how we will be able to mitigate the carbon dioxide emissions with the adaptation of sustainable fuels. What are sustainable fuels? Are fuels that emit less carbon dioxide through their life cycle compared to the conventional fossil fuels, which are extracted from the sources. So these fuels can be produced from the carbon dioxide storage and processing, or there is a recent renewed interest by the European Union from biomass conversion. What is important is up to the year 2050 to get net zero carbon dioxide economies for a better environment, quality of life, health indices will improve. And why do we do this? There are some challenges to meet. It was mentioned earlier in the introduction that within 40 kilometers from the coast, people are affected by the emissions of vessels. We see a typical caricature of a vessel with all the sources of pollution, and we see that the environment is highly affected. Of course, there are international maritime organization strict rules and regulations, EU regulations, which try to mitigate or regulate and control this pollution. But if there is not a driver for getting improved designs, improved systems, better combustion with sustainable fuels, this cannot be done only by regulations. Regulations and policies drive research and vice versa. This is my point of view in this talk. And what we see here, we see a lot of equations. The main point is that we have a fuel that is burned and there is combustion. From basic principles, this is, all of you have seen this, or most of you have seen this equation. We can make an energy balance and a mass balance in order to calculate emissions. So I use this methodology to calculate an indicator of how many what amount of carbon dioxide is produced per produced energy unit by the engine. A big vessel engine which drives vessels, or a big truck engine, or a big bus engine that travels in Berlin or in Valencia or in Limassol, emits carbon dioxide along with other pollutants that they were introduced in the previous panels, like sulfur oxides, nitrogen oxides, but the main point here is to reduce carbon dioxide emissions. So what was done, a comparison between diesel fuel, heavy fuel oil, biodiesel and natural gas was done, and we have seen that the emissions, this indicator is reduced. Now the data, how the data is related with these calculations, we need to get real time cloud-based data recording in order to assess different routes, coastal or open sea operation of vessels, and quantify this amount of emissions and optimize vessel route, or even intervene in the load or speed and make a reduction of the emitted pollutants. Of course, there is a big list of suggestions. We need experiments, we need data, and of course the last one, we need to utilize a huge data set in order to complement our investigations. So it's a collaborative effort, and to complement my presentation, the existing material that I have already explained, I did a SWOT analysis, which stands for strengths, weaknesses, opportunities, and threats regarding research, and I list here what are the strengths. We have researchers. What are the weaknesses? We have unevenly distributed research infrastructures. The calls are very competitive, so we need together to think and write down better proposals in order to get funding that will drive research and community wealth in this direction. And of course, the opportunities are here within the EU-CONEXUS partners, and we have the threats. One of these threats is the pandemic. Another one is the war conflicts that affect the environment, of course, and also the balance and stability in international and European relations. There are the challenges are listed here regarding carrying out research, and what is proposed carefully leverage the artificial intelligence tools, including machine learning, which is more focused with supervised or unsupervised training of models, in order to get a better degree of accuracy upon validation of the methodologies used in order to quantify the emissions and how the environment is affected. And by trying to answer the question, if we look at the previous figure, the graph, for the short-term reduction of emissions, what is existing now, and the infrastructure is there, at least for maritime vessels, is the dual fuel application of natural gas at wider range. Now 1.5% of the marine vessels only use natural gas, which directly will reduce up to 25 to 30% the carbon dioxide emissions. This will be a transition fuel until the most important new fuels will be introduced, given that the infrastructure will be mature, developed, and available, not only at the pilot scale that is now investigated in many research labs. Thank you for your attention, and we'll be able to take any questions.
Thank you. Thank you, Sharon. I'm sure everyone will have many questions after that very informative presentation. Thank you. And so now in another scientific field, we welcome Dr. Dimitrios Skleros, who is a microbiologist working at the Agricultural University of Athens. He researches marine microbiology, environmental molecular biology and biotechnology, particularly virus-microbe interactions. He also studies environmental microbiomes and their correlations with urban and coastal ecosystems. So Dimitrios is going to respond to the question how molecular biology can assist in generating data for urban areas to promote sustainability. Thanks.
Valencia. I will start with my presentation. My expertise is on environmental molecular biology. So the thematic topic is about data and how can assist us. I'm not sure how aware is everyone, how familiar is everyone with molecular biology and with microbiology, but climate change and in combination with modern lifestyle is reorganizing what we call microbiomes. If you are not very familiar with microbiomes, I will just say the term. It's the collection of different microorganisms like bacteria, viruses, fungi, and what we like to call as unseen majority. Here is a paper from 2019 where scientists warn humanity about microorganisms and climate change, because we talk about climate change, but we have a very anthropocentric point of view. We only think about ourselves, but climate change is not only affecting ourselves, it's also affecting microbiomes, it's also affecting all animal life and marine life. So subsequently, these microbes, unfortunately, as we have seen in the past, and I will show you today, can affect human health, can affect our plans of how we think every day clinical and human health. So how we what we do in the lab and what scientists all over the world try to do is we have coined some new terms, not so new for me, but maybe new for the public, called environmental DNA and environmental RNA. These are like barcodes today for us. We can sequence from the environment, environmental DNA, environmental RNA, and identify putative pathogens, microbes that we cannot see with our naked eye, but we can see their genetic signature in the environment. And of course, science is not only for monitoring, it's not only for reporting results. Science is here for us because most importantly is able or should be able to forecast incidents. But for this, not only my specialty is required, it's a multidisciplinary field of action that requires microbiologists, virologists, epidemiologists, bioinformaticians, people that are very familiar with AI and machine learning, and maybe some more specialties which I'm not referring to this slide, and of course, most importantly, policymakers. Because now, in 2025, we have well-curated databases for microbiomes available related to public health. How we do that in the lab, quickly, we are involving a technology called next-generation sequencing. We are able now to isolate from the environment, as I told you before, DNA and RNA, and with a lot of bioinformatician, technical and bioinformatic workflows, and to get some results to understand how climate change and anthropogenic activities are shaping microbiomes in urban and coastal environments. Of course, if in the future, or I will show you one example that we have already done it, we incorporate artificial intelligence and machine learning approaches, we can faster and better get results about public health. Here I choose to show you some pathogens, marine pathogens, opportunistic pathogens that a lot of urban cities like Athens and probably Valencia have problems. These are natural occurring organisms in the environments, in marine environments, but with climate change and wastewaters and all the anthropogenetic modern lifestyle we do can become putative, pathogenic. But this is not a new story. This is a story that we have already examined in the past during the COVID-19 pandemic. I don't know how you remember this pandemic, but at least in Athens, where we used to sample from wastewater treatment facilities samples, isolate RNA and monitor COVID-19 molecularly. And back then, environmental data scientists teamed up with epidemiologists, and they were able to predict what is going to happen with outbreaks and the pandemic locally in this city over the course of a few weeks or a couple of months. But only today, this is a publication from this year, 2025, we were able to build reliable models with epidemiologists, because now we have a lot of data and we can forecast outbreaks for new variants. So we learned a lot from SARS-CoV-2 pandemic, and in the lab, because I was told that I have to show some work from my lab also. In the lab, we did something similar, but with an aquaculture-related, we had an aquaculture-related example. We screened environmental DNA from hatcheries in Greece, from East Mediterranean, and we were able to identify microbes that are not pathogenic, or at least we didn't know that were pathogenic, but emerge as putative pathogenic in the future. One idea of this is Tenacibaculum genus, which was known to scientists only like some species like 20 years ago, but only now some specific species we were able to identify and take actions. Aquaculture, which is a private sector in Greece, and Spain also is a big market for Greek aquaculture, took action about this. So I'm just going to show a small figure that I quickly made about what I'm trying to tell to you. It's important today, 2025, to sample environmental DNA, to generate data. We need people to assist us on interpreting this data, and we believe that AI can help incorporate it to basically to faster take action, to faster take decision-making for public health initiatives and actions. Of course, we still are aware that we need geographically tailor-made algorithms for this, and that's why AI is a new field, but we need people to get involved to design algorithms like this. Of course, here it's only me from the lab. I'm presenting this work. I'm part of the Laboratory of Environmental Biotechnology from the Agricultural University of Athens with Professor and Lab Director Manolis Flemetakis, which you can address him as head of LSBI Institute also. And of course, I'm just presenting a work that is backed from a lot of people in the lab, a lot of intensive work, and a lot of ideas around. Thank you for your attention.
Thank you, Demetrius. And last but definitely not least, we have Georgetta Bourdieu, who's an assistant professor in natural language processing for digital humanities at La Rochelle University. Georgetta researches knowledge extraction from news archives and analysing cultural reception. She has developed evaluation frameworks for taxonomy extraction and one of the first multilingual data sets in the field. So very interestingly now, Georgetta is going to look at how we can use large language models and how they can help us better understand data. Thanks.
So my question?
So your question is, how can LLMs help us to understand or visualize data?
So hi everyone, thank you Susan for the introduction, and also thanks for all the panel members. They've done a great job getting everyone excited about the environment and then also sustainability. So this makes my job a lot easier. And to answer, the short answer to the question is something like to have impact, we don't have actually, you cannot use only factual data. So we like factual data, we're all scientists in the room, but to have impact on policy, on society, we actually need good stories. So that's my short answer to the question, and now for my long. So, this one? Oh, too fast. I will go ahead and introduce a little bit the research lab where I'm working. So it's a computer science research lab, so that's why I have my background in natural language processing, and we have about 100 members, and out of these members we have 11 full professors, but of course, like we've heard at the beginning, the inspiration comes from the PhD students, so we have something like 40 PhD students working in 3 different teams. And the team I'm working on is the images and contents team, and we're dealing with something like acquisition, processing, analysis of contents, different types of content, so images, text, sound, other types of signals, but also knowledge extraction and representation. So we're using machine learning, AI, to do clustering, classification, to do indexing, search, and exploration. So the great part about working in this research lab is that we're based somewhere around here, so if we ever have like a very long call, we can go like all the way to the beach here, and then for extra long calls you can actually go along the coastline. So that makes like already a good day for research. My job here in this research lab is actually a 5-year position to work on digital humanities and to try to apply natural language processing in this field, but also to work on computational social science. So now getting back to narratives and why do we need good stories to sell the data that we're producing. So I'll start with just a simple definition. So a narrative usually is a sequence of events. And all these events have to be connected in a coherent manner. Now, this is very important for people at the cognitive level because we can deduce from all the actors involved in the stories, we can infer very easily goals, motivations, and then plans for these actors. So a way to do this is actually to understand better a narrative is to build narrative maps. So this is a visual representation that can assist analysts to understand better the story. Now, if you couple this with something like called a semantic interaction model, so this is a model that tries to infer characteristics of the data based on the interests of the user, we can end up with a value chain, something like this. So my work is natural language processing, so usually we deal with large amounts of text. And we can go and build, like using a large language model, we can build something like text embeddings. So we go from the text to something like a vectorial representation. Then we can actually organize, structure this using clustering. We group the vectors that we can derive from data with the embeddings. But now we cannot stop here. So actually what we need is structure. So this is the story part. And here we can have algorithms that actually bring out the connections between the data points. And now we can have a full pipeline here of post-processing where we can get all these different lines, all these different connections in a graph between data points and actually try to bring out the stories. So the powerful tools that we have at our disposition to actually make impact. We can prune some of the edges. So from the graph, we can end up with something like this. So here you see 2 different storylines. We can further remove some of the edges that are not very important and to end with something like a final narrative map. So this is what the analyst sees. Now, we're all familiar with the part where we're doing data analysis. So this is the part on the left side here. We're doing data analysis because we want to do data enrichment and also because we want to extract insights. But this part here is something that actually is not really that obvious, and that a part where we can use quite a lot large language models. So to the different data points, we need to add logic, so connect the elements with logic, and then also we need to add structure. And the way that large language models can do this is very easily through summarization, doing bringing out the titles for the elements that we have, bringing out the captions for the images, and also automating annotation, and then also having like different explanation, textual form of explanation. So all this makes actually a lot more sense afterwards for the user. We don't just have a chart or an image, but we have a full story that is built through, along the data. And now a part that is usually not necessarily ignored, but it's actually very hard to do, is the interaction part. So we have to keep in mind that people want to explore our data. So if you just present static information, this is actually interesting to some level, but actually cannot bring us further to discover new insights. So on the interaction side, actually large language models can help us to do chart interpretation and then also data navigation. So the user can explore and go further and find more detailed information. Now, I chose to highlight not as much my work, but work from our university, and also a broader work from the EU-CONEXUS that actually inspired some of the work that I will present afterwards to conclude. This is a work that I found very interesting from our university in La Rochelle, and these are researchers that noticed that floods are happening actually as a sequence. So they have a repeated pattern. And we saw this actually in recent years, so with high intensity floods in Europe, in UK, in Central Europe, in North and Western Europe. So we have different waves of floods that occur in a sequence. And now researchers at the University of La Rochelle, they looked into a full field that is called historical hydrology, where they're trying to analyze, of course, historical and field resources to try to get some of these patterns about the floods. So they're looking at reconstructing maps of the spatial extent of these types of events. So the idea is that once you do that, so you have like hundreds and hundreds of years of data that you can analyze and check to see how floods are clustering, then you can actually have long-term trends, and also you can have prediction of future events. So of course you can imagine this is a kind of data set where you really have to dig through a large amounts of data set, and you really have to bring out the story to actually discover the sequences, and then to bring us to the conclusion and also to the prediction part. Then I was very inspired by work here at Catholic University of Valencia, and this work is actually interested more in storms. So the motivation of this work is that we used to have like very large events like storms, something like once in a century. But by the years of 2050, so not so far, in our lifetime, or in my lifetime, I hope, we will have these types of events almost yearly. So now, in this case, like this is for me, it's a very powerful story. How can you address this problem? So, of course, we have solutions like technical solutions with remote sensing, where we can put sensor and then estimate the erosion and the flooding. But the problem is that we cannot put sensors on a large scale. So for a small region, we can do this. On a large scale, this doesn't work. So now, the idea that I found really brilliant from a researcher here in Valencia is that they thought, why not use newspapers? So we can go to articles, we do manual analysis this time of newspapers, and then we can actually get information, very detailed information about the erosion, the inundation, the sand accumulation, the destruction of infrastructure. All this information is actually already in newspapers. So now, when I saw this work, I only imagined like the huge amount of work they had to do this analysis. And of course, I thought, natural language processing can step in, and large language models as well. So large language models would be able to actually look at a large amount of data at newspaper archives and pull out this information. Actually, the conclusion of this work is that we have good correlation. So we have good, actually, information that we can extract and from the newspapers. And also, if we compare this to inundation indexes, the information is actually quite accurate. So the information is there. Now we need large language models to pull it out. And these two works actually inspired this PhD opportunity that I would like to advertise. So it's a co-tutel. In this case, we will have one supervisor in La Rochelle, and the other supervisor will be in Bucharest at the Civil Engineering University. And what we do here is we look at these two types of events, so floods and storms, but we try to look at the impact on historical buildings. So as you can see here, you can see traces on this tower. They actually come from these types of events, and we would like to look at historical records and try to pull out using, of course, generative AI, so large language models, and knowledge-driven approaches. So looking at the archives and trying to point all these events and link them to the impact on historical buildings. And now, we got the funding. Now we have to find the right student to bring to our lab. And I would just if you have any of your students that have already a master's degree, the deadline for the application is end of December, and then we would expect them to start next year in September or October. Thank you so much. I have two key takeaways, but this time not from computer science, but from humanities. So first of all, a story is actually an art of work. A good story is an art of work. And secondly, to appreciate a poem, you actually cannot summarize it. So you actually have to go and look at the full content. Thank you.
Thank you. Thank you, Georgette, and to all of our panelists. As you'll see, we have very wide-ranging research from the macro right down to the meso level. So now we'd like to open the floor to questions. Does anyone have a question for any of our panelists or the collective panel? Yeah, at the back. Right.
This is the reason why I think that the picture must be bigger related to the footprint of carbon.
Yes, thank you for the very specific question. The idea is to examine this on big marine vessels, this approach with alternative new fuels. Since these new fuels are improving environment, so less carbon dioxide is produced, then the alternative fuels can be also used for heavy truck engines. However, this is not readily available in terms that the engines should be retrofitted and cannot operate with the natural gas, which is the recommended solution. For big marine vessel engines, because the marine engine can burn a wide range of fuels because of slow speed engine, high pressure injection. So that was the focus. But of course, it can be applied also to trucks, trailers, buses, and this covers all the environment, urban, the coastal, and the open sea. So adapting new fuels will dramatically decrease carbon dioxide emissions, and is very urgent. Thank you for your question.
Thank you. Do we have any other questions for any of the panelists? Yeah.
It's not it's not a question. My name is Jaroslav Dvorak from Klaipėda University. I want to start discussion with Professor Henrik Jansen about his last recommendation about trust, because actually our research, which we done on evidence-based used in smart cities, shows that the trust in you mentioned it, that we must share more data that create more trust, something like that. And our research show that it's very complicated to create trust. And I think maybe Mrs. Gemma Royko Palardo can also say on that, because we found that there are different formats of the data, first of all, and this is one of the ways that trust is not able, and especially if we are talking about cities and coastal area. So again, different government, they have different formats, and again, the sharing data is not creating the trust, because this data actually is not able to be linked between each other, so that we have some figure. Again, I don't know about the case of Valencia so many, but I think that they are also, in case of smart city, a lot of things are outsourced from private sector, and it means that a lot of data, again, in the case of private service providers, so it again means that to create trust by data very complicated, because usually municipalities are not have enough capacity to do that. So this is some points in the discussion. Maybe you can provide some more explanation. Thank you.
Okay, maybe what I presented is, of course, from the experience we made in the projects that we did, and we saw that when you have urban planning projects, usually a lot of people and general public is affected by that, because sometimes you have neighborhoods, something is changing, building is being added, and so on. So people sometimes want to be involved into certain decision makings, and we at least discovered that the more we provide them on which basis, on which laws, on which restrictions we are doing these decisions that we're doing, the more trust is there that things might be necessary. Not everyone will agree on that, and not everyone will support decision, but I think that we can see that people at least gain more trust that planners and engineers are not doing things because they want to do it like this, but because there's reasons, because there's maybe restrictions, maybe there's laws. For example, we experienced that a lot of people, at least in Germany, are not aware of the building laws, so they don't know what is possible, what is restricted, and how a neighborhood can be developed. And so in our cases, we experienced that there is a lot of trust that people are getting by providing them the data that you're using to plan. Maybe you can add this up, I don't know.
Specifically related to the trust of data and to sharing data within public and private companies. As you can imagine, the path to be a smart city from the beginning till now historically is a very long path and complicated. At the beginning we had all the information in the city by silos. It has been a really, really hard work to integrate everything in this same platform. It's important for the different departments to understand that if everything is possible, if it's possible to have everything in the same platform, then it will be possible to analyze together, to mix together and to get some information. But we can see that right now, not every one of the departments of the City Council is integrated in the same platform. So most difficult is to bring the information for the public, for the private, as you was commenting. But anyway, the City Council is investing a lot of efforts in order to achieve this, and in fact, instead we don't have all the information together and all the information coming from the private together with us. The information that the City Council has itself is a lot. It's a lot and can be mixed with all the information that today we can bring for the geospatial analysis, for example, from satellites or from other companies, sometimes small companies that are analyzing this information and could bring us lot of data to have the possibility to take decisions. I think is more than the quantity of data we have and the quality of them, is most important to have the possibility of analyzing them together and exploit it. In fact, if you can imagine that, the City Council of Valencia has its administrative platform, electronic administrative platform, launched since 2012. In this platform, all the requests that every citizen do to the City Council is registered electronically. For example, if you want to build any kind of shop, a grocery shop, this request is registered electronically in the City Council. It has happened from 2012. All this kind of information that is together in the City Council, but right now we still don't have the way to exploit it and to analyze it. It's incredible. And right now with artificial intelligence issues and solutions, we start to have an idea about how to exploit it together. For example, I think that more than the thing of the trust and of the quality of the data is most important the way as we have the possibility to exploit it. Because the data we have is good and maybe the quantity is also good, even we don't have everything. But with the data we have, we could take some decisions and some good results.
Thank you. So education, awareness, transparency is really what you're talking about with the data.
Not only just transparency for the citizenship, but also a good way for taking informed decisions.
Great, thanks. Yeah, Yvonne.
Thanks. Yvonne Kavanagh, SETU. A question for Hendrik and for Gemma that leads on nicely from the last talk there. Geolocation. So you've got the people, you know where they are. You can now geolocate people to within about a couple of meters. So are you using that data to verify the models that you've used, for example, planning in the city in particular? Have you actually used that data and put it over and actually analysed how people use the space after you plan it? Or are you still getting there? How's that journey going? Thanks.
So for the cases that I presented here, we have not done it yet, because it's so far it's only concepts that have to be implemented, and as you might know, I know urban planning projects take a long time until they're realized. So it will take some time until we can check this and know if it really works. But so far we have not real data that we can compare with the planning that we're doing. So it's more in a concept phase right now.
In our case, we are now trying to put in work our digital teams. So maybe in next years we will have the possibility to have this feedback.
Thanks. I think we have time for one more further question. Yeah.
Okay. Well, I'm Jose Tena from UCB. And first time, congratulations for all the speakers, because I think it's very interesting, all the things that we can do with all the data, no? But I would like to ask some short question for Dimitrios, okay? Because we are starting to work in environmental DNA to check or for monitoring coastal areas. What do you think about the possibility to use this new technology for not only for microbiome? The idea is, do you think it could be possible to use for new species present in the area, like exotic species or invasive species, or to check the change of the temperature or salinity, etc., in the what do you think about this?
So I'm going to keep this like this because it doesn't work with my Greek ears. So Yes, yes, of course. And we have done in the past. We can correlate data, environmental data related with molecular biology, with seasonality, with different conditions. For example, I showed an example with hatcheries. All these hatcheries didn't have the same conditions, so we tried to correlate data based on their different approaches of how they have protocols for their hatcheries, and they have much differences, which also was influencing the microbiome. And we can apply this to other species, to other ideas, and as we have progressed now to 2025, this is something important and probably applies to all what we discussed. In molecular biology, we have open data, which means that if I want to publish the research work, means that I firstly need to deposit my molecular biology data to a public database, which is going to be available for everyone, forever also. And then I'm going to publish my research based on this data. But someone else, another scientist, can use this data and mine information for different questions, for different hypotheses. So to answer your question, yes. And now in 2025, this technology is relatively much cheaper than it used to be, I would say, just 5 years ago. So yes, it's plausible, and hopefully we can collaborate and make this happen.
Perfect. We will talk about this.
Thanks. Yeah, one more question.
Mohamed Gamal from the University of Rostock. Well, I'm an urban planner who is highly interested in qualitative analysis and research. So my question is related to the last presentation. I do believe that narratives and empirical research are a very strong tool to understand our world, but now you argue that it can help us to gain more acceptance and more kind of support from the political arena. So, would you give some concrete examples of how this can be achieved?
Well, already, I'm not sure if we have some people that are working on policy in the room, and already like showing the mathematical formulas, even for some researchers, make us run away. So I think you can already see the part that had a good story to sell. So already from the storylines that we had today in the room, you can see what sells and what does not. So like keeping things short, having a story, if you can bring in characters that make the story more active, all these things are actually having more impact than just like raw data and charts and numbers and I'm sorry to say mathematical formulas.
Yeah, of course. I mean, the narrative can drive us to the equations and the equations to the solution of a real problem. So it's the base.
But the difference is the audience.
The audience, okay.
So shaping the message for the right audience, and I think we have the right audience in this room. So we have a lot of researchers in the room. But like when we're talking to policymakers, maybe the message can be shaped differently. And I'm a computer scientist. I'm still learning how to do that better. But it's just to show that we need to introduce this kind of courses for our scientists. So how to do public communication and how to shape your message towards the audience, to targeted audience.
Absolutely, and that's probably why most Horizons EU funding now really mandates arts and humanities involvement. I'm not just saying that because that's my area, but there is a real necessity for us not just, to translate our data and our findings for the general public, not just subject discipline experts. So yeah, thank you for that. Is there any further questions? No? Yeah, Mike.
I just ask one on, Henrik, you talked about the density. Henrik, you talked at the start about the density and cities and so on, and the need then for actually having cities to get more population dense. What about the social impact of that? And I know in another question you kind of talked about, you know, the role of people there and so on. But is that not does that lead to a lot of social problems then when you're trying to kind of basically bring buildings up, cram more people in, you know, less green, maybe, I don't know, less green space if there's more buildings going in and so on? And how receptive are people to that idea?
Well, you're making an absolute relevant point. Because of course, when you are working within existing built structures, you are kind of interfering into the everyday life of a lot of people that live there. So of course, they don't want things to change. They want to live as they did before. But at the same time, in the case of Berlin, the city is growing, a lot of people are coming in, and what we want to prevent as urban planners is that the city sprawls outside, you know, so we want to try to keep it compact. And also, I mean, that's probably special about Berlin because it was divided and has this former eastern part that has a lot of Soviet structured housing neighborhoods, and they're not very dense, you know, so you do actually have a lot of space to kind of re-densify them. At the same time, of course, you might know also that Berlin is a very left city, and especially in the former eastern part, a lot of people are not really okay with this developments of having their neighborhoods being changed. So, of course, what we can do with these tools and with our concept is to make a proposal, but of course, this is not giving us a final decision, you know. This is just the basis to get into talks and to get into workshops, to talk with the people on what is options that might be okay, what is options that might be not okay. It's a kind of negotiation process, you know, between the citizens and the planning makers. But at least I have the feeling, or we had the feeling, that giving them certain tools also to visualize how things would look like, what kind of shading this might create, what kind of open space they might get for it, is at least giving a basis to have a discussion about this. But of course, it's leading to a lot of social problems if you are only doing certain kind of housing, because the most needed housing, of course, is affordable housing. And a lot of people, at least from the private sector, are not focusing so much on that. So this is all questions that are not answered, of course, with a tool, you know, because they go far beyond that. But the tool might be a basis to discuss all of these questions. Yeah.
Thank you. Anyone else? I think we've covered a lot of ground in terms of data-driven decision-making, but also how it crosses over so many domains when we think about sustainability. So I want to thank all of our panelists for your time and expertise, and thank you all, and thank you for the questions. And I think that we definitely have earned a glass of nice wine this evening. So thank you, everyone. Well done. Thank you.